What a great day! I'm Algebra from BS Ed Math 2B, and this is the exercise 1.2, number 23. Here, we will solve the system using either Gaussian elimination with back substitution or Gauss-Jordan elimination. And our problem here is this. X plus 2y is equal to 7 and 2x plus y is equal to 8. So first, let's get the augmented matrix for this system. So let's draw a bracket first. So the value or the coefficient of x in our first equation is 1 and the x in second equation is 2. And the coefficient of y here is 2 and in our second equation is 1. Then let's put some bracket here that is kind of like they equal. Then put the constants, which are the 7 and 8. So yeah, now our goal here, or our first goal here, is to change this 2 to 0. So for that, we need to think a formula to change that, and we will use this formula: negative 2 times row 1 plus row 2, and that will be the new value of row 2. So negative 2 times row 1, so negative 2 times negative 2 times 1, that is negative 2. Negative 2 times negative 2, and negative 2 times negative or positive 2, that is negative 4. Then negative 2 times 7, that is negative 14. And then we need to add it in row 2. So negative 2 plus 2, that is 0. Negative 4 plus 1, that is negative 3. Negative 14 plus 8, that is negative 6. So let's rewrite it. Okay, our new matrix. So we have 1, 2. Row 1 will be, or will stay the same, 7. Then our new value for the second row is 0, negative 3, and negative 6. So now our next goal is to change this 3 to 1, and for that we need to, or we will just simply divide it by itself. So that is, so here we will use the formula r, or row 2 divided by negative 3. So row 2 divided by negative 3, that is negative 3 divided by negative 3, that is 1. Then negative 6 divided by 3, that is 2. So our final matrix here is 1, 0, 2, 1, then 7, 2. That is our final matrix. And our next step, or next goal is, or next step is convert it back to a system of linear equations. And for that, don't forget that this is the value of x, this is the value of y, and this is the constant. So our first equation, x is equal to 1. So x plus 2y is equal to 7. Then since we don't have, or the value of x here is 0, so we don't need to put that anymore. Then y is equal to 1, so y, then the constant is 2. Now since we have this y is equal to 2, we only need to find is the value of x. For that, using back substitution, okay, using back substitution, the x, using back substitution, x plus 2, the value of y, let's substitute the value of y, which is the 2 is equal to 7. So x plus 4 is equal to 7. So using additive inverse, x plus 4 minus 4 is equal to 7 minus 4. So x is equal to 3. Okay. Now, to check that, we only need, or we will put it to the original equation. Okay, let's apply it so the value of x, our value of x here is x is equal to 3 and y is equal to 2. So let's substitute or apply it here. First equation, x is 3, so 3 plus 2 times 2 is equal to 7. So 3 plus 4 is equal to 7, so 7 is equal to 7. That's right. Then the second equation, 2, the x value, 3 plus y, that is 2, is equal to 8. So 2 times 3, 6 plus 2 is equal to 8. So 8 is equal to 8. That is correct. So that is my solution for exercise 1.2 number 23. Again, I'm Aljon Balyan from BS Ed Math 2B. Thank you.